All right, welcome everyone. Going to give folks a few moments to join, and then we'll get started with a quick introduction, show you guys some helpful resources for after today's webinar. All right, looks like we've got a good amount of folks already jumping in. So thank you everyone who is joining us today for Understanding Thermally Modified Wood. It's presented by Geanna with the ArborWood team today. Before we jump into the CEU portion of today's event, I'm just going to give a quick introduction about Acelab. We're helping out with hosting today's webinar. We'll show you some helpful resources on our platform if you're interested in learning some more about today's presenters after this webinar. Our website is a great place to come for that. So I'll share some helpful links in the chat throughout today's presentation as well. But first, just want to show you guys how to get in touch with the ArborWood team, as well as view some more information about their products if you're interested in learning some more about their company specifically after today's event. You can always use the search bar at the top, type in the name of any brand, any product that you're looking for. It'll cross-search between product categories, brands, and resources on Acelab, and you can use that to just jump over to their page. From here, you can get in touch with their team directly. So you can click this button, get in touch with Geanna if you've got some more questions that come up after today's webinar. If you want to connect about a project, this is a great place to come. Scrolling down here, you can view some more information about their company, watch some videos to kind of get introduced to their company in general, and then you can explore a bunch of their products. You can save these to your account for future reference. So that's a great way to kind of, store your product information along with any of the communication that you've got going on. And then you can open up any of these product pages, view some more information, download spec files, view a product description, get an idea of the certifications, as well as download some additional resources. So if you're looking for any of that type of support after today's webinar, I'll send over a link to the ArborWood page in the chat. You can also let us know towards the end of today's webinar if you're interested in getting connected with their team for some additional information. We'll go ahead and connect you through your Acelab account. You'll have an email about that you can respond to, but you can also always open your Acelab account and navigate to all of your conversations by clicking this icon in the top right. That'll bring you to a page with an overview of any of the communication that you've had going through this platform. So if you've attended a bunch of webinars with us in the past, this is a great place to come and just check in on some of the resources that have been sent to you after a webinar. All right. A few housekeeping items for me before we jump into the CEU. Just want to really encourage folks to please ask questions throughout today's event. We'll keep our eye on those. We should have some time to get to some live. If we don't get to your question live, we'll have a record of it so that the team can follow up with you after today's webinar. Last thing is this is an AIA-approved webinar. We did ask for AIA numbers upon registration. I'll also send over a form in the chat momentarily. So if you feel like you need to submit your AIA number there, or if you need to specifically request a certificate, you can do that there as well. If you've come to a bunch of webinars with us in the past, that information gets auto-saved, so you don't need to fill it out again, but it'll be there in case you need to. All right, that should be it for me. Keep your eyes on the chat for any helpful links or resources that you might need. Use the Q&A for any questions, and then we should be all set. Geanna, whenever you're ready, feel free to go ahead and get started.
Okay, let me share my screen here. Let me make this, everyone see my screen?
Yep, looks great.
Okay, sounds good. This CES, we will discuss understanding thermally modified wood. It is accredited with the AIA for one health, safety, and welfare learning unit. I will record your attendance with the AIA, and for anybody who wants to self-report, I can issue you a certificate. It is also accredited with the Interior Design Continuing Education Council for one learning unit as well. And you can also self-report for landscape architects as well. This course will explore the process of thermal modification. Thermal modification is a tested and proven process that increases the dimensional stability, durability, and the performance of the wood while sustaining all the natural beauty without harsh chemicals. Thermal modification is done with just heat and steam. There are no chemicals in the process at all. It's a very sustainable product and it can be incorporated into a variety of your projects. I'll give you a second here just to read over the learning objectives, just so you can get a brief understanding on what those learning objectives are. And then we'll go into the introductory. As architects and designers, you guys love to use wood in your projects. Wood is natural, it's renewable, it's easy to work with, and it's readily available. As you know, there are a lot of challenges when using wood as far as like durability, decay, ongoing maintenance, inconsistency in moisture, and the availability of high quality wood. Recently, there's been a greater focus on embodied carbons that had led to the increase of wood in building design. And methods like thermal modification increase durability, but reduce the overall maintenance when you're using wood in your projects. There's been several different processes to increase wood performance. As you know, pressure treated wood, they use a bunch of chemicals to impregnate the wood. Most pressure treated wood is going to be softwood. You cannot impregnate a hardwood. So all of your pressure treated is going to be like your Doug fir, your soft species. Then the Japanese invented the Shoshugiban process, which involves charring the wood to protect the exterior from water and other decay. There's different painting and staining methods that you can do to add a protective layer that prevents water and UV from getting into the wood, but they require a lot of maintenance. Thermal modification is where we just use heat and steam to modify the cellular structure. It collapses that lignin and makes the wood more dimensionally stable and a lot more durable. Thermal modification is done with just heat and steam. There are no chemicals when you're thermally modifying wood. It takes place in a thermokiln. It's a bit like you're baking bread in this massive kiln where it increases the temperature to about 400 degrees. What that does is it removes all the moisture and sugar content from the wood cells. If you were to look at wood under a microscope, wood has little lignits that hold the moisture in, and your standard wood is going to be like a 19 to 22% moisture content. So the heat renders the wood hydrophobic. So what that means is it absorbs a lot less moisture. Thermally modified wood absorbs 50% less moisture and it retains 30% less heat. It's a really good alternative to like composite decking, where composite gets really hot and you don't want any maintenance. You can offer thermally modified wood in your projects, let it weather and go gray, no maintenance. It's going to get a lot less hot. The process cooks out all of the sugars, all of the food source. So there's nothing left to rot, mold, mildew. Um, it absorbs so much less moisture. It gets less hotter. There's no sugars. There's no food source. So it's termite resistant. For people in the West Coast where termites are a huge issue, thermally modified wood is termite resistant because there's no food source. There's no sugar for the critters to eat. It is not woodpecker resistant. We do get asked that question a lot because woodpeckers are going after the wood fibers as a nesting animal. The thermal modification process was invented many moons ago by the Vikings to protect their ships from the harsh sea conditions. And then the Japanese art known as Shoshugiban, where they would char the exterior of the wood, also increased the performance and durability of the siding. The thermowood process was developed in Finland in the 1990s. They reintroduced it to building products. Reason why you see a lot of your big European players that have been around for 30 years came out of Europe. You're starting to see a lot more people come into the US doing thermal modification as well. Different species that you will see for thermal modification. White ash is definitely the premium product. Red oak started to come into the marketplace when there was some questions about, hey, what's going on with white ash? We've seen a lot of white ash start to slow down because of the emerald borer bug, but then they started to research and do more studies and noticed that the emerald borer was really attacking the black ash and not the white ash. Most white ash is sourced here in North America. So your European players are sourcing ash in America, modifying it there, sending it back here. You'll also see red oak came into play recently just because of what was going on with the white ash market. Red oak has the exact same mechanical properties of white ash. It has that really beautiful cathedral grain. It almost looks identical. You'll see pine is going to be a soft species that you'll see a lot. The American players use more of like a southern yellow pine, which is going to be a clear grade. The European players will do more of a Scots pine, which has that really nice distinctive butterfly knot. You'll also see spruce. Spruce is a really nice rugged wide board. You can get like up to 9-inch decking with spruce. A lot of the spruce is coming out of Northern Europe. In America, we do not have good spruce here to source for modification. We would have to go really far north into Canada to get a really good quality spruce. Hickory and hemlock, you'll also see hemlock does not have a lot of sugars. So when you modify hemlock, it still stays really nice and light in color. Normally when you're cooking out the white ash, because there's so much starch and sugar in the white ash, it goes in white and it almost comes out looking like a dark walnut. So at the end of the slide, we'll kind of show you some samples and you can see how the modified white ash looks and the pine and spruce. But hemlock is really great application for soffits because it remains really light in color. It doesn't turn to that really nice dark color. Your most popular species you're going to see are definitely going to be ash and pine across all markets. This here shows a picture of the open system. This is the thermowood process that was started, the whole thermowood process out of Europe. They're a Yartek clave. What you do is you take your select kiln dried wood that's at the 12, 14, 16% moisture content, and you put it in this kiln. You cook it for 48 hours. That changes the cellular structure, removes all the moisture and sugar content, making it hydrophobic. It breaks the hydroxyl group, and that's where you get the breakdown of that cellular structure. This here kind of shows you the 3 different phases. Phase 1 is where you're increasing the temperature of the wood, removing all of your moisture and content, taking it down to a 0. Phase 2 is where you get to that really, really high heat, over about 400 degrees Fahrenheit. It's almost to a combustion point. You're removing the oxygen from the kiln, therefore the wood does not burn. So this is the phase where your thermal modification takes place. Phase 3, which is probably the most important phase during the thermal modification, is the cooling down phase where you start to increase the steam back into the boards. You really want to make sure the boards are at that 5 to 6% moisture content. So when they acclimate, they only acclimate by 1%. So you're getting about a 6 to 7% moisture content. That's where you get your dimensional stability. That's where you get wood that doesn't cup, warp, move, expand, or contract. Reason why thermally modified wood has become such a hype word in the industry in the US in the last 7 years is it's so much more dimensionally stable. You don't get movement. Most of the players offer a 20-year warranty against rot and decay, major surface checking. So you're going to get a beautiful, nice, durable piece of wood. This here shows the closed system. This is some new technology that was invented in Europe. You're starting to see a lot of the players use the closed system on softwoods. It's still a pressurized system. There's no oxygen, but there's no steam in this process. You're just taking the moisture content down to about a 5 to 6%, and then they're using nitrogen in here. So it's a little bit of a different system. You'll only want to do softwoods, much smaller batches, and you can do it in about 8 to 12 hours. So it's a little bit lesser of a system instead of the big Yartek system that was invented by the European players. Benefits of using thermally modified wood. It's very solid and stable. It's easy to work with. You don't get the movement like you do in normal wood. It becomes hydrophobic, as I mentioned. It absorbs 50% less moisture and it retains 30% less heat. It does not rot, mold, mildew. It doesn't fungus. Doesn't grow any like a fungal decay. It's easy to work with. You don't have to pre-drill. If you have contractors or the architects, you guys have been specifying epay, you know how hard epay is to work with. You have to pre-drill epay. It will tear up your saws. Thermally modified ash looks identical to epay. You're not cutting down the rainforest. It's much easier to install. It'll go down about 50% faster. So once architects and designers start specifying thermally modified ash over epay, the contractors love it because it's so much easier to work with. It's very lightweight. Again, it's at that 5 to 6% moisture content, so very easy to work with. And it has a really nice appearance where the thermal modification tone is all the way through the board. This here is a great chart because it shows you the durability on how wood is rated. All wood is rated 1 through 5 in the durability. Class 1 is going to be your highest rating. Thermally modified ash is a class 1 durability. So what that means is it has a 25-year plus rot resistance durability rating. Just like your teaks and your epes that are so sought after because of that dimensional stability, that's where your white ash is going to fall. 25-year plus, you're going to get out of your deck or your siding projects. Thermally modified pine is a class 2. So what that means is it has a 15 to 25-year rot resistance durability rating. If you're comparing that to cedar, and so many projects, they specify cedar because of like price point. Cedar is going to be a class 3. Cedar is going to rot out in about 8 to 15 years. Thermally modified wood, it just improves your dimensional stability. It's a great thermal insulation. It has a beautiful color and tone all the way through the board, and it's insect and mold resistant. It's equal to your tropical woods in durability. It's got a better dimensional stability, and it comes in a little bit less than Ipe as far as price point. It's beautiful. It's long lasting. You can see in this picture, this is Marvin's headquarters out of Minnesota. You can use it, go with no maintenance, no need to oil it, just let it go gray. It's going to have a beautiful life cycle analysis. You don't have to do anything to it. So it's got a nice lifespan and a lot less maintenance. Applications for thermally modified wood. A lot of the building products are focused on exterior siding, decking, dimensional lumber. We do a lot of soffit and fascia. We have a lot of great architectural millwork as far as your dimensional lumber, like 2x4 all the way up to 2x12 material. So pretty much if you want it milled into any specific product, such as interior flooring, you can do interior flooring as well. You can also create a profile and have it milled into anything. We work with a lot of the site pieces on architectural millwork as far as like Nova wood, Sitescapes, and those guys specify a lot of thermally modified ash. We also do some tolling for Fender. They make a lot of musical instruments out of it. And then you can also do interior applications. Some of the European players will have a Thermo S versus Thermo D. And just so you know, Thermo D stands for durability. That's going to be all of your exterior building products where they're cooked to a much more extensive thermal modification where they're cooking it for the 48 hours. Thermo S stands for stability, and that's going to be cooked for a lot less time. You'll use those applications for interior where they're much lighter in color, or they'll use those for sauna parts as well. Installation and maintenance. It is a wood product, so you do have to fur it out to allow for a rain screen to allow for airflow. So you'll want to make sure you have the siding furred out. Decking is available in a hidden clip and a non-grooved clip, so you could face screw if you choose to. Again, you don't have to pre-drill. They do have plugs available in any spots where you are face screwing. It is such a premium product. I would highly advise from face screwing and go with the hidden fasten decking system. It's much easier to work with. For siding, you're just going to blind fasten through the tongue at a 45-degree angle. Most manufacturers are going to have like a nickel gap, which gives you that really nice contemporary shadow line, or you can do a nice V groove for your tongue and groove. Different finishes that are available. We do recommend that you do seal up all the end cuts. It was a living tissue at one time, so moisture will travel through that capillary, and that's where you're going to get checking if you don't seal up the end cuts. If you want the wood to weather, you don't have to do anything to the wood, just let it go gray. If you want to maintain the original finish, then you do have to apply an oil on top. For the ash, because it comes out looking like a nice dark walnut, you can use like a walnut or an espresso color tone. A lot of the high-end modifiers will use Q-Tech because Q-Tech is a really high-end penetrating wood. Again, it becomes hydrophobic, so it absorbs a lot less moisture. You really want to make sure you're using a really high-end penetrating oil. That's why you'll see a lot of people using the Q-Tech. They have several different colors. several different pigments, but keep in mind, it is the pigment that protects it from the UV. You will see manufacturers that specify softwoods that come oiled, or redwood, the red oak that'll come oiled. It's just oiled with a clear oil. The clear oil does not protect it from UV. So if you want to maintain the original color, that's where you have to put some type of pigment into the clear oil. A deck will have to be reapplied once a year. Siding will have to be reapplied about every 2 to 3 years, depending on elevation and exposure. Thermally modified wood does weather much faster than non-modified wood, so it will gray out. Like I said, a deck will go gray in about 8 to 12 months. It's a combination of UV and moisture that makes the wood weather. So if you're in a really dry climate and you're not getting a lot of moisture, you may get a little bit longer life before you start to see the product go gray. I always let clients know the wood will tell you when it needs to be reapplied. If you want to maintain the original color, you'll start to see the water stop beating off the surface. You'll start to see it go into this blonde phase. This slide here shows you how the wood evolves. This also shows you a color spectrum. As you guys know, wood is a natural product, so it depends on the food sources in the ground that are feeding the wood for your color consistency. Sometimes we have to really explain that to homeowners. They may get a sample in their architectural box and it could be a little bit darker than what they get. Sometimes there'll be a little bit lighter boards in there, but there is an approved color spectrum when you're working with thermally modified ash, and it shows you here how dark it can be and then how light the color variance can be, but it does go blonde before it goes gray. The gray color is absolutely stunning. The white ash has such a beautiful cathedral grain that when it weathers, that grain really pops. If you want to go lighter in color for like your siding application, you really have to let that evolve naturally because it's modified wood. We're cooking all the sugars out. It's darkening the wood. It's hard to go lighter until you just naturally let that evolve. So then you can install it, oil it down with your lighter color tone in about a year as it's starting to evolve on its way to going gray. If you want to go darker, Q-Tech has several different color tones as far as like red hues, yellow hues, some black ash, beautiful colors. They even have like a smoky gray that you can give like a pre-weathered gray look. So there are several different applications. I urge you to check out Q-Tech's website, look at some of their color tones on different species. They have several different thermally modified wood species, and we can always get you some samples for your projects. But this here just kind of gives you a good idea of what the wood looks like when it weathers. Sustainability, thermally modified wood has a lot to offer regarding sustainability as like embodied carbons. It's great for biophilic design. We have all sorts of LEED certifications, Living Building Challenge. We also have a Declare label. EPDs and HPDs are all available from all the different manufacturers. Designers have been looking for different alternatives to carbon and steel because of the carbon footprints and everything. And as you know, wood is renewable and it's a natural source, but wood also acts like a carbon sink. So what that means is that wood is used and absorbed carbon from the atmosphere as it grows. The carbon is locked in and it's stored, so it prevents it from entering the atmosphere. There's been a greater shift in sustainability over the conversations in the last few years, focusing on more operation carbons and embodied carbons. So operation carbon is the carbon related to operating a building, and embodied carbon is the carbon used to harvest, transport, and manufacture the materials in the building. As we transfer the wood into the building products, that carbon is locked and it's stored into the building for a very long time. That prevents it from entering the atmosphere. There are several different green building rating systems that influence building and design. Different things to consider is how you produce the products, where the products are coming from, how the product gets to the job site, and embodied carbons. So again, you'll want to look to like the European players and find out like where they're modifying their wood. You'll want to consider like more of the domestic players that are sourcing the white ash here in America, modifying it here in America. Start to consider like carbon footprint. Start to look at their EPDs. There's different lead points available when you're dealing with like a government project where you're trying to go for lead points. You can get FSC wood for your lead projects. FSC wood does drive the price up by about 30%. We don't stock FSC on the ground, so it's got to change some custody. A lot of the manufacturers have the chain of custody to get you your FSC. It's going to be longer lead times and it's going to be an additional upcharge by about 30%. There's other ways for you guys to get lead points. There's 3 points available for low emitting material. There's 2 points available for sourcing raw material, innovative design, as solar reflex index. You can also get points for that. Just kind of keep that in mind when you're working on your lead projects. What I'm seeing now is a lot of living building challenge projects. Living building challenge is like lead on steroids. With LBC, you absolutely have to have 100% FSC wood. There's no way around it when you're working with living building challenge. It has to be FSC. So again, a lot of the players in the industry can get that. We just kind of need to know ahead of time because it's becoming a sourcing issue with the ash and the pine. There's also declare labels that go along with Living Building Challenge. Thermally modified wood is red list free. There are no chemicals in the wood, so it's red list free. Other components can be red list approved, where there may be some chemicals, but they're red list approved. Ours is red list free. Every thermal modifier is red list free. Again, it's thermally modified with just heat and steam, no chemicals. Health Product Declarations, and HPD, provides a chemical inventory of the building products that are characterized in each ingredient. Again, thermally modified wood, it's just a wood product. It's modified with heat and steam. The HPDs are a helpful document in compliance with your LEED, your Living Building Challenge projects, and your well building. Again, all the sources are online. When you're dealing with any of the manufacturers, you can go to their website, download all of their HPDs. The EPDs as well. Most manufacturers have an EPD when it comes to thermally modified wood. An EPD is an environmental product declaration. It's based on specific rules and requirements. It's pretty much like a life cycle analysis as to what is in that building products, how you're manufacturing that building product. A lot of the European players just have an EPD that goes to like a cradle to gate. It stops at the manufacturing gate. So then you need to consider, okay, how are they getting this over here by container? And then it's got to come up from rail. A lot of the American companies will do a full cradle to grave EPD, which talks about the whole life cycle analysis and what they're doing with that wood once they're done with that project, how it's getting to the job site. A lot of the times they're just burning up the wood, using it as firewood because there's no chemicals in it. You can build it out into furniture pieces. It's really circulatory to be reused in that 30+ years. FSC, Forest Stewardship Council. Again, all the thermal modifiers can get FSC wood for your projects. FSC is the gold standard for sustainability managed forest. We do have the chain of custody when you're harvesting through a manufacturer. A lot of the times, because these thermal modifiers are dealing with distribution, you have to make sure that the distributor or the lumber yard that you're buying from has the chain of custody. When you're getting into FSC wood, no one can touch it if they do not have the chain of custody. So a lot of the times, and I just speak from my past, if we've had an FSC project and the distributor or the lumberyard doesn't have it, they can't touch it. We have to sell it right to the job site, but we'll still work with your people so they can get all their margins and everything in the distribution channels, but they just can't touch it because they lose that chain of custody. Carbon smart wood. This is a new category for sustainability wood where the guys from Carbon Smart Wood, they work with a lot of the, say like Patagonia, Amazon. You're getting all these big players that are coming in and building these massive warehouses. Well, unfortunately, when they come in and build those warehouses, the trees that they're cutting down, they just get chopped down, turned into mulch. Sometimes they're just getting burned. The guys from Carbon Smart Wood, they're diverting waste, they're creating jobs, and they're planting new trees. The red oak, a lot of the times they send the red oak back to one of the US modifiers. They will modify the red oak, put it back out there into the building product industry as carbon smart wood. I would check out the Cambion Carbon guys. They're a really great group of guys. They're all from Yale. They're doing a lot of good, diverting waste, creating new jobs, and just planting new trees. So a very sustainable. Summary is that thermally modified wood is more stable, it's durable, it's sustainable, and it's a beautiful option. It's less expensive than your tropical hardwoods, and it has that similar durability. And it's just a natural solution for aesthetics. Here we'll kind of go through some case studies just to show you some examples of thermally modified wood. This here is the Bell Museum in Minnesota, where we work specifically with Perkins and Will on this. They wanted to use white pine. We as a manufacturer, we don't have white pine. We use a southern yellow pine, so it's a clear grade. They wanted something very knotty. And there's a lot of white pine in Minnesota. So we had a good 3 years to do mechanical property testing with the NRRI out of Minnesota to do all of our testing. This has been up for several years. If you check out our website, you can see how it's weathering, but really beautiful for your projects. If there's a species that's invasive to your area and we've got enough time on a commercial project, we can open up the spec and look at other species. This here shows Epicurean corporate headquarters. This is thermally modified white ash, but this is kind of giving you a feel as how you can use it inside and outside and still have a nice cohesive look. Of course, we would have to oil all of the product if you want to maintain the exterior to not weather, then you just keep reapplying the oil on the exterior, but the interior is never going to weather because it's not going to get that UV and moisture. It's also great for interior ceilings and soffit applications that flow to the outside. Great for custom cabinets here. They did a lot of custom cabinets on this as well. This here is just a historic home that they did in Venice Beach. It was on Buying Beverly Hills. This kind of shows you an example of how southern yellow pine can actually live with the white ash. You see the southern yellow pine has that really distinctive grain on the fence, and then the deck is the ash as well as the interior flooring. This here's a project we worked on with Gensler in Los Angeles for the Del Rey campus. They bought a bunch of dimensional lumber from us and we milled it into a specific profile that they were looking for. You're starting to see a lot of that open joint rain screen system become very popular here in the US. It's huge in Europe. We can also source any of our dimensional lumber 2x2 all the way up to like 1x4 material for something like this. Thermally modified wood is great for boardwalks because it's hydrophobic. It's absorbing a lot less moisture. It's not going to react to huge temperature swings. So a lot of humid areas, you're seeing like elevated decks, you're seeing a lot of boardwalks, you're seeing a lot of terminals in the Pacific Northwest. They love the thermally modified ash because it is such a hard, dense wood. And again, no maintenance, just let it weather. You can do it for railing, you can use it for signage. A lot of boardwalk projects. This one here is also on our website. It's been down for several years now and it's gone completely gray. This here shows you how you can use it for site pieces. A lot of the times they're buying like the 8-quarter 2x4 or 2x8 material to build benches. Doesn't get nearly as hot. It doesn't splinter. So it's a great application for your high use benches. This here's a project of red oak. This kind of shows you that red oak looks very similar to white ash. It has that really nice cathedral grain. This here was an alternative to Ipe. They were looking for something more domestically sourced. They wanted to save the rainforest. So the red oak was a good alternative to Ipe for this project. And they're keeping this oiled, so it does stay that really nice, like red oak color. That is our presentation for thermally modified wood. Let's see if we can open it up for questions.
Awesome. Thank you so much, Gianna. Yes, we do have some questions already.
Okay.
And if anybody has additional questions, feel free to send them in the Q&A, or you could also raise your hand and we can unmute you if you've got like a longer winded question. You don't have to turn your video on, but that's an option if anybody would like to do that. All right, first off, will hemlock retain its color over time or will it age to a weathered gray?
Hemlock will go to a weathered gray as all wood weathers with the combination of UV and moisture. Hemlock just stays really light in color because there's not a lot of starch. So when you're cooking the wood, the starches are what caramelizes the wood and makes it turn to that really darker appearance.
Mhm. All right, great. Next one, this person says, thank you for the great presentation. So thank you for coming. I have a few questions. Where is your wood harvested? I can just go
All of
one by one if that sounds good. There's
Yeah,
quite a few.
so ArborWood is domestically modified here in the US. We're using let's see, I have a list of here. All of our southern yellow pine comes from North Carolina, Georgia, Alabama, Mississippi, and Tennessee. The ash is going to come from Tennessee, Kentucky, Virginia, West Virginia, Wisconsin, Ohio, and Indiana. And then our poplar, those are our three species we work with, are going to be more of the Midwest, Ohio, Indiana, Tennessee, and Kentucky. ArborWood is based out of our corporate headquarters is in Duluth, Minnesota, and our production facility is in St. Joe, Indiana. So we're an American company domestically sourcing wood here in America, modifying the wood here in America. So we're really vertically integrated because we're modifying it, we're milling it here, and then we're sending it out to our distribution companies in the East and West Coast.
Awesome. Great. Well, that answered their next two questions, which was where is it thermally modified? Where is your US inventory stored and shipped from? Next step is, are there products that are more readily available versus others?
We specialize in exterior building products. All of our processes are going to be that Thermo D, where they're cooked to that really extensive treatment for exterior use. We have tons of inventory on the ground here in the US. In the West Coast, we have distribution. We work with, say, BMD in California as our distributor, and in Colorado, Washington, Oregon, Idaho, Montana, that's going to be more Blue Links as our distributor. And then in the Midwest, we sell direct. And on the East Coast, we have distribution as Blue Links is really our national partner. And then we have a lot of dealers on the East Coast. So we normally want to follow like a two-step distribution. So we're selling to the distributor is selling to the local lumberyard. Most everything we have in our product catalog, we have inventory on the ground. Lead time, like 2 weeks from our distributor. If you get into something custom, like a special order where you're designing a knife, then you're talking like 4 to 6 week lead time. But because we're manufactured here in the US, we have 3 of the kilns here on the ground. We're modifying it, milling it. We probably have about 3 million in inventory on the ground.
Awesome. All right. Well, I think that answered the next one also, which was about if there are custom profiles available. So sounds like yes, it'll just be a bit longer of a lead time.
Yep.
Sense.
And we have thousands of knives. So if you get into something custom, I can send you the knife profiles we have. If it's a knife we don't have, then you get into like a $500 knife fee. If you're doing a custom order, because it's something we don't stock, we have to go with like a 30% overage just because of fall down after we're milling it. We want to make sure we have a little bit left on the ground or send you some extra. So there is a 30% overage instead of your standard like 8 to 10% overage that you would do with the standard order.
Okay, awesome. All right, next up, can you speed up the aging process to get the gray coloring faster?
Yes, you can. I've had job sites in Aspen where they would set the thermally modified wood down and hose it with water for 4 months. It will go completely gray at that altitude with that amount of UV. We've also had projects where they would try to bleach it. Of course, you're applying a chemical to this beautiful product that is done with just heat and steam. You kind of lose the sustainability approach, but it
Mhm.
does not void our warranty. So that will work. We also work with a product called Suex, and I may be saying that wrong. It's more like CU. They call it CU or Suex. The Americans will call it Suex. It's SIOOX. It's out of Sweden. It's a really fast acting accelerant. It's a 3-step process where it's a potassium and a silica base, but you apply that in our factory. We just did a hotel in Aspen that has 1x8 Suex, and it's stunning. It goes gray in about 90 days. It's more moisture than it is UV because the potassium has to crystallize, and then it
Mhm.
starts to react with the wood underneath it, and it advances the weathering. So about 90 days, you'll get a pre-weathered gray look.
Cool.
Or you can also do like the Q-Tech and go with the smoky gray. That's
Mhm.
more of a translucent color. It gives you that pre-weathered gray look because a lot of commercial projects, you'll have overhangs, you'll have different exposures that will weather at different rates. So if you want something more cohesive,
Mhm.
pre-weathered, then we could pre-finish it in the factory with the Q-Tech, or we could pre-finish it with the Suex. The Suex will gray out in about 45 to 90 days.
Awesome. All right, great. Next up, how does cost compare to non-modified wood of the same species?
No, I don't know what non-modified would cost. You're not going to have the dimensional stability. I could just tell you, I'll talk end user pricing too. So white ash is going to be our premium product. As a manufacturer, we want to have a good, better, best approach so we're not getting valued engineers. So the architects know what to specify. The white ash is going to be a premium product. If we're talking about, say, 4/4 inch siding or 4/4 inch decking, you're going to be about $16 to $18 a square foot for thermally modified white ash. And then you move into that middle price point, which is going to be our poplar. Poplar is going to be closer to like $8 to $10 a square foot. And then you move down to like our value line, which is going to be our southern yellow pine. That's going to be closer to like $6 a square foot. So you kind of have that good, better, best. You're going to be like
Right,
$6, $10, $18. The
right.
pine is about half the price of the white ash. All of the species we offer with ArborWood are going to be a clear grade. Your European players are going to have more of the knotty spruce and the knotty pine.
Mhm. Great. Next up, do you do rough finishes?
As far as like resawn, we can do resawn finishes. We can do wire brushing. We can do all sorts of different finishes. That just becomes custom. So we could do it for you in the factory, or we could send it to the job site. And sometimes they'll have like a local milling partner do that for you. But commercial projects, they almost want it done, shipped to the job site, ready to go. So absolutely, we can do all the different finishes for you.
Awesome. All right, great. Looks like the last one for now. Someone asking if they are able to get a copy of the presentation. They'd like to see some of the images more closely.
Yes, if you shoot me an email, I can send it to you. Some of our case studies all probably came off of our website. If you go to our resources on our website, there will be more like background about the case study. They'll show it from like day one install, and they'll also show it weathered. So yes, you can do that. You can also go on to AEC Daily, host
Mhm.
our CES if you wanted to like retake it to kind of take some notes.
Yeah,
It's also living on that platform as well.
awesome, great. And I did share a link to this page in the chat too. So we've got some case studies here on Acelab's platform as well. So that's another place to explore. But yeah, we've got a record of that, Steve. So we'll share that with the ArborWood team and they can get you that presentation. All right. It looks like that might be all of our questions for now. So if anybody has some questions that are coming up as you're leaving today's webinar, there will be a quick post-event survey that'll pop up on your screen. Feel free to leave any questions, comments, or feedback there as well. And then also before you head out, grab some of the links from the chat. If you need to explore some more about ArborWood, save their products, get in touch with their team, you can do that all on the link that we shared there. Awesome. Great. Looks like, yeah, just some thank yous coming in, no more questions. So we appreciate everyone for coming out today. I know it's almost holiday time. So thank y'all for coming and spending time with us during today's webinar. And thank you, Geanna, for such a great presentation.
Thank you.
All right. Have a good day, everyone.
Thanks.